This is Mark Pawlikowski, and welcome to the TechMates podcast, where my partner Henrik and I explore how Kiwi and Aussie founders are reshaping the future and what sets them apart. Henrik and I have been part of successful companies in Silicon Valley and Europe, and now bring that expertise to partner with entrepreneurs in Australasia. By sharing the personal stories of successful Kiwi and Aussie founders and how they got here, we hope to inspire you to dream big. This is TechMates, bringing an outsider's perspective to the stories of those daring to disrupt down under. Let's dive in.
So I'm just curious, what does it kind of mean to make one of these like carbon fiber alternative materials? What goes into it, right? So I understand you have a plant. You go from a plant to something very, very hard. How does that happen? What are the steps required to do that?
Yeah, that's a good question because it's a plant in the ground and a race car or a snowboard sitting there are two very just different things, right? So I guess you can preface it by saying like, there's a bit of an overview as well. So KiwiFibre is a natural fiber composite material, and it directly replaces carbon fiber and fiberglass. It solves technical and environmental challenges of global industries, and that's thanks to its properties like radio transparency, vibration damping, etc. The way that composites are made is you start with a fabric, and that fabric then is flimsy and it's flexible, which means that it can fully drape itself around a 3D shape, which means that the benefit in composites compared to other materials is that you can achieve crazy shapes, like the shapes that you see or the geometries that you see in cars or in boats or in bicycles, for instance. They're all these wacky, like crazy geometric shapes. You can't economically or technically make those from traditional materials like woods or plastics, or even if you can, you don't get the strength requirements. And so there's a specific use case in which you use composites instead of another material. And it's basically for strength or lightweightness or because it's a crazy shape. Like thinking things like wind turbines, for instance, those need to be a very specific engineered flex, and they need to be a very specific weight and all this kind of thing. There's all these requirements, and you can achieve those through composites. So the way that you make let's just say a race car front bumper from a composite. So normally you take the mold, which is like a negative imprint of the actual bumper. And then that mold, you lay up all of the fabric that's cut to shape. So you just basically place bits of fabric inside that mold. And then you place a vacuum bag over the top of it, and you draw resin, which is like a glue, under vacuum using an air compressor. And you basically draw that resin through all of the fabric that's sitting inside that mold, and it fully impregnates all of the fibers. And then you basically place that system into an autoclave, which is a big oven, and then it sets and it cures the glue or the resin, and then you end up with a rigid fabric, which is the composite part. And that's the process which is followed for basically every industry in the world that is a tangible thing. So that's things like boats and submarine, automotive, infrastructure, mobility, transportation, sports equipment, aviation, aerospace. All of those industries use composites in that exact same way. And KiwiFibre can be used the exact same way. You don't need to replace processes. You don't need to redesign the product to use a new material to an extent. It's basically just a drag and drop replacement. So instead of using a fabric that's made from oil or a fabric that's made from incinerated sand, which is what carbon fiber and fiberglass are, you just lay a fabric made from harakeke in there. And so what we've developed is the way to make that fabric from the plant.